Welcome to my channel. Today we are going to discuss about the realization of IIR system. Okay, this realization of IIR system, this is under the unit 2, design of IIR system and realization. Okay, so first one, we have to discuss about how to realize this IIR system. So first, what is mean by IIR? IIR means infinite impulse response system. Okay, so infinite impulse response means the impulse response h of n of the system is having infinite values. Okay, so that h of n is available. For example, h of n equal to a power n u of n. Okay, so for n equal to 0, the h of n is having some value a power 0. Then at n equal to 1, a power 1. At n equal to 2, a power 2. Up to n equal to infinity also, the impulse response is available. So for the time n equal to 0 to infinity, the impulse response is available means that is said to be the infinite impulse response system. So the next unit is a FIR. FIR means finite impulse response. So the impulse response is having some finite sequence means it is called as a FIR. Okay. So now we have to realize this IIR system. So already we studied the realization in signals and system also. Okay. The realization of continuous time system and the realization of a discrete system we discussed. So that the realization of the discrete system itself, there are two types. One is realization of IIR and another one is a realization of FIR. So that FIR we discussed, we will discuss in the next unit. So now we have to see about the realization of IIR. Okay, so first one, in the realization, so first the IIR system, the infinite impulse response system, can be described by the following difference equation. Okay, so the discrete systems are mentioned by the difference equation. So this is a one nth order IIR system general equation. Okay, so the output of that IIR system y of n, it can be written as minus summation k equal to 1 to capital N a k y of n minus k plus summation k equal to 0 to m bk into x of n minus k. So this is said to be the one nth order system, nth order IIR system general equation. So where this y of n is the output and y of n minus k, where k, you see the k is some constant, it will vary from 1 to n. So y of n minus k, if k equal to 1 means y of n minus 1. Y of n minus 1 means it is a delayed output, 1 second delayed output. Then y of n minus 2 means 2 time delayed output. Similarly, for k equal to n, nth time delayed output. Okay. And what is this x of n minus k means x of n is said to be input and x of n minus 1 is a 1 second delayed input. Similarly, x of n minus k means generally k time the delayed input. So the output of that particular system is depending upon the input x of n and x of n minus 1, that is the previous input, x of n minus 2, that previous input, as well as y of n minus k, it is called as a previous outputs. Okay, so the present output of the system, it depends upon present input, past input, as well as the past output. This is said to be the IIR system. Okay, so where this AK, okay, so you see this here, there is a two very constant is there, AK and BK. What is this AK and BK means? This is the IIR filter coefficients. Okay, so this where k equal to 1 to n. So there are the coefficient a1, a2 up to n number of a coefficient. Similarly, k equal to 0 to m bk. Okay, so m plus 1 number of the b coefficient is also there. So where the ak and bk is said to be the filter coefficients. Okay, so this is the time domain equation. So in order to realize the system in either direct form 1, that is there are different structures are there. Okay, there are different ways of realizing the IIR system is there. So already in signals we discussed. Okay, so already you know this. The first form is direct form 1 and the second one is direct form 2. The third one is cascade form, then parallel form and a transposed direct form and a lattice structure form. So these are all the different ways of realizing the IIR system. So in the realization, so we are going to use the three elements. One is adder and another one is the multiplier and the next one is a that is delay block. Okay, so already you're familiar that one. Okay, so if you want to learn more about what are the elements used in that realization of system means, so I will give the a link in the description box in the signals and system video. Okay, you can check. Okay, so here what are the blocks where basic elements used to realize this IR system means, one is adder. Okay, this is the adder, and this one, this arrow mark in a line, we are putting one arrow, and in that arrow if you are writing some value means this is said to be the scalar multiplier, and this one, this Z inverse block, it is said to be the delay element. Okay, unit delay element. So these are all the three blocks in order to realize IR system in any form. Okay, so in order to realize the given system in this any one of the form, so first we have to that is we needed the h of z. What is mean by h of z? The h of z is nothing but the transfer function of the system. Okay, so what is mean by transfer function? The transfer function of the system is nothing but it's a ratio of Z transform of the output divided by the Z transform of the input. That is the capital Y of Z divided by the capital X of Z. It is said to be the transfer function. Okay. So if you want to find this H of Z, so first one, but here in our problem, there will be a time domain equation is there. Okay. The system equation in time domain is there. So now we have to convert this time domain into Z domain. Okay. So that's why, so we have to take Z transform for the above equation. Okay, just take Z transform for the above equation using the property, that is the time shifting property of Z transform. So what is the Z transform of the term Y of n? It is Y of Z. Okay, capital Y of Z, which is equal to minus summation k equal to 1 to n. Ak is a constant, so you keep Ak as it is. Then what is the Z transform of this Y of n minus k? What is Y of n minus k? It is a delayed output. Okay, so already we studied that is the time shifting property of Z transform in signals and system. Okay, so using the property of that Z transform, so the that is the time shifting property of this Y of n minus k, it is nothing but Z power the minus k into capital Y of Z. Okay, so as per the property Z transform, time shifting property of Z transform, the Z transform of the term Y of n minus k is Z power minus k into Y of Z. Similarly, plus summation k equal to 0 to m bk into what is the Z transform of x of n minus k? It's a Z power minus k into x of Z. Okay, so we taken the Z transform. Then you just collect y of Z, that is output term one side and x input term one side. So that's why you give this term. Okay, this complete term you give it to this left side. Okay, you give it to left side. So we can write it as y of Z plus summation k equal to 1 to n ak Z power minus k Y of Z, which is equal to write this term. So in this first two term, Y of Z is common. So you take Y of Z as a common. So we have to write 1 plus summation k equal to 1 to n ak Z power minus k, which is equal to this thing. Okay, so from this what we want the transfer function. So that's why the transfer function h of Z equal to this Y of Z divided by the x of Z. So we can written as summation k equal to 0 to m bk Z power minus k divided by 1 plus summation k equal to 1 to n ak Z power minus k. So this is the general equation. Okay, this is the nth order IIR system transfer function equation. Okay, so you know down. So you have to remember this one, the transfer function of the nth order. Okay, what is mean by the nth order means the highest power of the denominator term Z power, it is called as the order of the system. So this is the general IIR system transfer function. So you just remember this one, summation k equal to 0 to m bk Z power minus k. In numerator the coefficient is bk divided by 1 plus summation k equal to 1 to n. Okay, in the denominator the term is capital N, the coefficient ak into Z power minus k. So this is said to be the transfer function of one general IR system. Okay, so if you are expanding this summation, okay, so you just expand the summation in a numerator and a denominator. So if you are expanding the summation, first you put a k equal to 0 here. So we can write b naught into z power 0, it's 1. Plus if you are substituting k equal to 1 means b1 z power minus 1. Similarly, if you are putting k equal to 2, b2 z power minus 2. So etc. up to what is the final value? Bm z power minus m. Similarly, divided by in here 1 plus a1 z power minus 1 plus a2 z power minus 2 plus etc. up to an z power minus n. Okay, so this is the general form of this is the transfer function. Okay, the general transfer function of our IIR system. So in order to realize in any direct form 1, 2, 3, direct form 1 and 2, cascade and parallel form, you just remember this transfer function equation. Okay, b naught plus b1 z inverse plus b2 z power minus 2 etc. up to some value divided by in denominator you see 1. Okay, the first value is 1, not a naught. Okay, 1 plus a1 z power minus 1 plus a2 z power minus 2 etc. Okay, so where this b naught b1 b2 etc. up to bm, similarly a1 a2 up to an, these are all the IIR filter coefficients or IIR system coefficients. Okay, next one. So there are already, there are different types of realization of IR system is that direct form 1, 2, cascade, parallel, transposed direct form and a lattice structure form. Okay. So now we will see about the one by one. What is the general thing we will discuss in this thing. In the next video, we are going to solve the problem. Okay. So what is the direct form 1 structure? Okay. So already now we are going to realize the direct form 1 structure. So in order to realize the direct form 1 structure, so first the transfer function. Okay, so one nth order IR system transfer function h of z, so you just write the h of z is equal to b naught plus b1 z inverse plus b2 z power minus 2 divided by 1 plus a1 z inverse plus this thing. Okay, so if this is the transfer function of one IIR system means the direct form 1 structure is that this is the one. Okay, so you just remember this. This is the direct form 1 structure. So in direct form 1 already in direct form 1 the integrators, that is the delay element. The delay element is available in the first. Okay, this is the delay element is at inverse block. So the delay elements are available in the diagram first and last. Okay, the adders are available in a center. In a direct form 2, it is reverse. In direct form 2, the delay elements are available in a center. That is, the delay element is shared by the two sides. Okay. And the adders are available in a first and last thing. Okay. This is the difference between the direct form 1 and 2 structure. And in the direct form 2, so if you are realizing one system, instead of direct form 1, if you are realizing in direct form 2 means automatically the number of delay element, that is the Z inverse block used automatically reduces. Okay, so you see this is the direct form 1. So here we used, so here 1 3 delay element, here 3 delay element we used. But in order to realize the same system in direct form 2, so you see only the 3 delay elements are used commonly. Okay, so this delay element output is shared by the two sides. Okay, so that is the greatest advantage of this direct form 2 structure. Okay, number of elements used is reduced by half the amount. Okay, number of delay element used in the direct form 2 structure reduces the half amount when compared to the direct form 1. That is the advantage of direct form 2. Okay, so the direct form 1 structure, this is the direct form 1 structure of this IR system. So here how can you draw means, so this is the input, x of z is the input. Okay, this is the input line, this is the output line y of z. Okay, so this half diagram you see the x of z is given to a series of delay element z inverse block. Okay, then the first x of z is multiplied with the coefficient b naught. Okay, so which one is a b naught? In the h of z equation, the numerator term you see, the numerator, the first term is b naught, the second term is b1 z inverse. Okay, so in this case, this first half diagram, okay, the first half diagram is nothing but this numerator. So this numerator is achieved by what is the first term b naught. So you see this is the b naught plus b1 z inverse. So the B1 Z inverse is achieved by this x of z is delayed by one time and multiplied with b1, and after 2 time delay we have to multiply with the coefficient bn. Similarly we have to use m number of delay element. The last delay element is multiplied with the coefficient bm. So you see this one is a bm, and we have to add two outputs we have to add using one adder. So for this last two line we have to use one adder, then output of this adder and this adder is added using this one, and output of this one and this one is added using one adder. Okay, so this is the first half of the diagram. So you just remember this diagram. Direct form 1 means this is the general structure. Okay, so the coefficient b0, b1, b2, etc. up to bm. Similarly, in the next half of diagram, you see here adders and here the delay element. The y of z is given to first delay element, second delay element, and etc. up to the nth delay element. And this factor. Okay, so in the first line, without delay this multiplier is 1, and in that delay, okay, after delaying the first output we have to multiply with the minus a1 coefficient. Okay, so here b0, b1, b2, but here you see the first one is the direction, you see 1. Okay, left to right, but here you see the direction, the multiplier direction is right to left. So with the value is minus a1. Similarly the next one is minus a2, etc. up to minus an. Okay, so these a1, a2, a coefficients are you see in the denominator coefficient a1, a2, but here minus a1, minus a2, minus an. Okay, so this is the direct form 1 structure. Okay. Similarly, if we want to realize the same h of z in direct form 2 structure means, so you see this is the direct form 2 structure. So in the direct form 2 structure, the elements are that is displaced. Okay. So in center we are using the delay element z inverse block. The z inverse block is called as unit delay element, and adders are used in first and last. Okay. So you just remember this one. Since the direct form 2 is the base in order to realize, in order to implement the cascade form and parallel form. Okay, so that's why the direct form 2 is very important. So in this method, so this is the input x of z, this one is the output y of z, and center we have to use delay element, and this delay element, the output of the first delay element is, okay, you see we taken two branches, one branch to left side, another one branch to right side. So in the left side branch you multiply with the denominator coefficient minus a1, the next thing minus a2, etc. up to minus an. Similarly the right side we are using the numerator coefficient b0, b1, b2, etc. up to bm. Okay, and similarly you just add two outputs, you just add using one adder. Okay, so this is said to be the y of z. Okay, so you just compare the direct form 1 and 2. In direct form 1, in first half of the diagram, the coefficient, the numerator coefficient b0, b1, b2, bm is there. In the second half of the diagram, minus a1, minus a2, minus a3 is there. Okay, this 1 minus a1, minus a2 is there. But in the direct form 2 diagram, in first half 1. Okay, so here there is a 1 is there. Okay, so here 1 minus a1, minus a2, minus an is there. So in the second half of the diagram, b0, b1, b2, bm is there. Okay, this is the direct form 2 structure. Okay, similarly the next thing we are going to see about the cascade form realization. Okay, so in cascade form realization, so already you know the name cascade. What does it mean by cascade? That is in direct form, either direct form 1 and direct form 2 realization. What is the disadvantage means? So if you are implementing the higher order system, okay, so which one is said to be the higher order system? That is the order n equal to 10, 8, 7 and etc. Okay, so when we are implementing that higher order system, the number of delay element used is also increases. Okay, so if we want to implement the third order system means we must use the 3 delay element. In order to implement that 10th order system means we have to use 10 delay element. Okay, so each delay, that is the name itself, it produces some amount of delay. Okay, so then if you are applying the input, you just consider when we are applying the input at a time t equal to 0, then in which time we will take the output at a time t equal to 0. If you are measuring the output means we will get the output, no. Okay, so it will take some time. Okay, since each input signal is processed via the various elements. Okay, so here you see the x of z is propagating via this adder and the first delay, second delay, third delay. Similarly, after delaying, we have to multiply this multiplier, okay, using this multiplier, and again adder, and again it will come to here. So the input signals are processed via so many elements. Okay, so already you know each element is producing some amount of delay. Okay, that is in order to produce the output, it will take some time in the range of nanoseconds or microseconds or milliseconds. Okay, so if you are implementing the higher order system, that is the order is 10, 20, 30, etc. For example, you just consider each delay element is produces 1 millisecond delay. Means if you are implementing the 10th order system, means so after 10 millisecond only we will get the output. Okay, so if you are applying the input at a time t equal to 0, but if you are measuring the output at the same time, we will not get the output. Okay, after time t equal to that amount of delay only we will get the output. Okay, so that's why instead of using this in order to reduce the delay produced in the direct form 2, so we are moving to the cascade form or parallel form. Okay, so in cascade form realization, the given the higher order system, okay, the transfer function h of z, okay, h of z is said to be the transfer function of the given system. That a transfer function of the given system, we can split into the product of single order systems. Okay, so you see the h of z, it can be splitted as h1 into h2 into up to etc hk of z. Okay, so here where what is h1 and h2 and h3 etc means it is a single order system. So in cascade form, the higher order system, the 10th order system is splitted into the product of 10 number of the single order systems. Okay, and we have to realize this single order system separately in direct form 2. Okay, so the h1 of z we have to realize in direct form 2, h2 of z we have to realize in direct form 2, etc. And finally, all diagram we have to connect it in cascade. Okay, so this you see, this is the h1 of z diagram. Okay, this is the block diagram. So in the h1 of z, you just replace the direct form 2 of the first system. Okay, similarly here we have to place the direct form 2 structure of the second system and so on. So and all system you just connected in cascade means this is the cascade form realization. Okay, so in this cascade form realization, so the delay is reduces when compared to the direct form 2. Okay, this is the thing. So you see in cascade form realization, the transfer function h of z, okay, the transfer function h of z, it can be expressed as a product of number of first order sections. So you see h of z equal to, this is the product. Okay, product of I equal to 1 to k h I of z. That means put I equal to 1, h1, I equal to 2, h2, etc. up to hk. So h of z can be split as h1 into h2 into etc. up to this thing. Okay, and this individual transfer function, the next step is to the individual transfer function can be realized either in direct form 1 or direct form 2. Okay, so maximum you may select direct form 2 since you are having the advantage is that in direct form 2 the number of delay element is reduced by half the amount. Okay, so that's why instead of direct form 1 you may use direct form 2 in order to realize. Okay, and finally we have to connect it in cascade as shown in the figure. Okay, so after realizing h1 separately, h2 separately, h3 separately, finally you just connect h1, h2, h3 in a cascade. What does mean by cascade? The output of the first system is given as an input to the second system. Output of the second system is given as the input to the third system and so on. It is said to be the cascade connection. Okay. Then the fourth form, it is said to be the parallel form realization. So in parallel form realization, so in cascade form realization, so we are writing the h of z, the total transfer function can be written as a product of first order functions. Okay, in parallel form realization, the total transfer function h of z can be expressed as a addition of the single order function. Okay, so first one c, the c is a constant. Okay, some constant plus h1 of z plus h2 of z, etc. Okay, so where h1, h2, h3 is said to be the single order transfer function. So using the partial fraction method, okay, so using partial fraction method, the given h of z can be splitted as addition of h1 plus h2 plus h3, etc. Okay, and after splitting like this, we have to realize the h1 of z, h2 of z, h3 of z separately, individually in direct form too. And finally, we have to connect like parallel form, we have to connect. So you see, this is the parallel connection. H1 is the first order transfer function. This is the second transfer function, third transfer function, etc. So finally, all direct form 2 diagram, we have to connect it in parallel. Okay. So in parallel, what is mean by parallel? For all system, we have to give the common input x of z, and output of all system is added. That output is said to be the output y of z. This is said to be the parallel form. But in cascade form, you see, the input is applied to only the first system. Output of the first system is given to the input of second. Output of the second system is given to the input to the third. And output of the last system is the output of our overall output. Okay, but here you see, input is given, the x of z is given to all individual systems. Okay, and output of all system is added using adder. Okay, that is our resulting output. So this is called as a parallel form realization. Okay, so these are all the four different realization of our IIR system. Okay, so in the next video, so we are going to discuss about the problem related with this realization. Okay, so all problems, so we are going to solve the three problems. So three problems are already asked Anna University questions. Okay, so thanks for watching my channel, and please subscribe my channel for more videos, and thank you.